This is Nithya Aston, Professor, Department of Mathematics. So today we are going to see the unit 5, limit of a function. This is the last unit in the real analysis 1. So in this we are going to say the basic introduction as well as the metric space, limit point, continuous function definitions also. These are all the important definitions. So just go through it. First one, metric space. Let X be a set and a metric for X is a function D with a domain X cross X and a range 0 to infinity such that it has a following condition. If it satisfies all these conditions, then we can call that as a X comma D is denoted as a metric space. So let X be a set, any set you can take, and a function X is a function of with the domain X cross X. So we have the mapping from X function to X function, and it is a range, that is a limit is 0 to infinity. So such that it has to satisfy the following condition, that is d of x comma y greater than or equal to 0, then d of x comma y equal to 0 if and only if x equal to y, and d of x comma y equal to d of y comma x, d of x comma y less than or equal to d of xz plus d of zy. So this is a, if it should satisfy all the conditions, then we can call that as it is a metric space. Next example for this, R is a set of real number. The function d from R cross R to R defined by d of x comma y is equal to modulus of x comma y. So where x comma y belongs to the real line R. So this is a metric space. Another one, R squared is a ordered pair, set of all ordered pair. Then R squared cross R squared tends to R. It is defined as d of x comma y equal to x1 minus y1 the whole square plus x2 minus y2 the whole square the whole power 1 by 2. Where x is equal to x1 x2 and y equal to y1 y2. These are all the examples of the metric space. Next one, limit point definition. Let x comma d be a metric space. A point P belongs to X set to be a limit point of a set S belongs to X if every neighborhood of P contains a point of S different from P. That is, if let us taking the metric space x comma d. Here a point we are taking P that belongs to X, that is called as a limit point of the set we are taking S belongs to S. So it is every neighborhood of that point contains a point of S which is different from P, that is called as a limit point. Now continuous function on metric space. So let x1 comma d1 and x2 d2 can be any two metric spaces. We are taking two metric spaces. A function f from x to y is said to be a continuous. When we are telling that the function is a continuous function at a point a of x for epsilon greater than 0, that there exists delta the element such that so d1 of x comma a is less than delta implies d2 of f of x comma f of a less than epsilon. If it satisfies this condition, then f is a continuous at every point of x. So it is a continuous on x. So these are all the basic definitions in the last unit. It's a very smallest unit. Just go through it. Thank you. Thanks for watching.